Thank you, Dave. I've done this many times before. The important part of this, when Dave asked me to do, is talk about hose integrity. Hose integrity also goes into hose safety and the longevity of the hoses we use. Is anybody aware of how much a 20-foot chemical hose costs? Anybody? Any ideas? $700, $1,200? That's what one hose costs. Now, that's not the real cost of a hose failing. The reason we're giving this is to, number one, is to stop from some operator getting hurt. That's our primary objective. No other objective is more important than keeping the operator safe. The second objective is to keep accidents from happening. A lot of hoses create a lot of accidents, and this is what this is all going to be about, okay? This is going to be a very informal meeting. Anytime you have questions, please ask. We'll be passing things around. I'll be asking questions, and I'll be asking questions after I tell you some things. I'll be asking you what I talked about, okay? Okay. The following procedures that extend the useful life of a hose we'll cover now, okay? Before we go, does anybody recognize this type of hose in the plants? What's the hose used for, please?
Air hose.
Air hose. What kind of pressure on the air hose?
About 250 psi.
Okay. Do you have a safety feature on that where it won't go over 250? Hoses are designed specifically for specific things. An air hose is designed for 200 pounds, 300 pounds, 400 pounds. This particular hose, if you look, is a 300-pound hose. So make sure that your plants where you have them don't exceed the pressure of this hose and have some safety valving involved that it doesn't go over the maximum working pressure of the hose. That's the first hose you use. Does anybody recognize this type of hose? Okay. It's a composite chemical hose. That's correct. This hose was invented in World War II when all of the rubber products in England were being diverted to the war efforts. So they didn't have rubber to make hose with to load and unload. So what they did, some inventor came in and took a helical wire, just like this is outside, took a helical wire, wrapped it in plastic, and kept wrapping it in plastic, and then rewrapped it in another helical wire. Therefore, they were able to transport chemicals and so whatever they needed. From that point on, it got much more sophisticated, but it was an excellent invention, and you use a lot of it today. Why do we use it? Why are we using this hose over this hose? We'll go over that a little bit. Okay, this hose. Has anybody seen this hose? And what is the function of this hose? Ma'am? Chemical hose. Okay? Chemicals go in it. Not every hose in a chemical plant is a chemical hose. The air hose cannot be used for chemicals. This hose has a special liner inside, and it's used for specific purposes. So the basic hoses you use, this type of chemical hose and this type of chemical hose. There's a reason why you use the two different hoses. Are there any other chemical hoses or hoses that you use?
Steam hoses.
You use steam hoses. Okay. I brought steam hoses as an example. This will start off why we're having this meeting. If you all take a look, this is a steam hose that's been used, improperly cared for. If you look, do you all see the breach? Created a big accident, burned somebody's face very, very seriously. This is why it's so important. What we're doing is how to take care of hoses. Okay, let's talk about the hoses themselves. Okay, what makes a hose a hose? There are three components to the basic hose and one other component. The three components are the tube. Can anybody tell me what the tube of the hose is for? And that's very simple. What does the tube do?
It protects it from the outside liner.
Now, the tube conveys the chemical, the gas, the material going through it. That's its only function. 30, 40 years ago, there were only 4 or 5 hoses. Today, there are thousands of hoses for very specific chemicals. So the tube, what the tube does is convey the chemicals going through it. Okay? The next component of the hose would be the braiding inside. And what would the braiding on the outer cover of that would be? The reinforcement. Pressure. Again, remember what I'm saying because I'm going to be asking you. You'll understand why. The pressure. This is what gives that tube the pressure to run the materials through. From anywhere from 5 pounds, 50 pounds, 100, 200, 300 pounds and up. What kind of pressure does your place use? Chemical plants? Maximum pressure hose. Does anybody know what pressures?
Usually around 150 or less.
Okay. Most of these hoses, the hoses you use are specifically designed for your pressure requirements. So the braiding, the reinforcements are made for the pressure rating of the hose. The more reinforcements, the higher the pressure ratings. So that's the purpose of that. Okay. Now, the third component of a hose is the cover. What is the cover for?
Protection.
I'm sorry?
Protection.
Protection,
Perfect.
identification.
Perfect. Perfect. Protection. It protects the braid. It protects the braid from breaking. Do you see? We'll get back to this again. That's why it's important when people, operators, use the hose. So these are the components of the hose. This hose is a little specific in that the cover and the protection and everything is more combined. The outer wire also gives it the ability for higher pressures, but also it protects more protection for the cover. The cover is I believe it's made out of polyethylene. The inner core of this hose is a polypropylene core, specifically designed for the chemicals you use, the stainless steel wires. You can get these hoses in different configurations. You can get them in coated poly, everything else like that. You use all stainless steel wires so it doesn't react with the chemicals you pump through it. Okay. Now, the temperature, as I said before, a temperature of this hose and this hose, temperature is very important for a hose. Again, it's specifically designed for specific purposes. When you use a hose like this, 180 degrees maximum, that's all it's designed for. A steam hose is designed for 350 degrees and the temperature, 350 degrees of temperature and pressure up to 1,200 pounds burst. Okay? Now, supposing you would have a hose like this, a red hose that it's black, and in lieu of the steam hose, you would put this into steam service. That's a literal accident happening. Okay? The bend radius. Getting back to this hose, you remember I said there's a specific reason why I use it? In blending plants, these hoses have a specific feature. If you look at the chemical hose, try and bend it. Anybody? Not too hard, but try and bend it. That's a 2-inch hose. Of course, as it gets longer, it bends easier. Okay. Yes?
The difference between that one and that one?
The difference?
In our plant, we use it on this one.
Which one? The composite. Okay. I'll tell you the difference. Okay. Go ahead and bend that.
But you can't bend it? I have muscles.
Okay. Now, here is a composite hose, and that'll answer your question. Try and bend this. Okay. This was inadvertent positive when they invented the hose, the flexibility of that hose. They've got further and further. In blending, you have to move around quickly in tight spots, and that's why you use that hose. It's a more expensive hose. If you don't need the flexibility of the hose, Then we'll go back to a chemical hose where you don't have much bendability. All these will bend on a 30-foot or 20-foot. It will bend. But that's why. The reason we have two, that's much more expensive than this. And if you don't need the flexibility, you know, you go with this. Right. This has a UHMW, ultra high molecular weight polyethylene tube in it. It's very hard, and it takes about 98% of all the chemicals that are made. Easily 98%. There's only one substance that's better, that's Teflon. But it's an excellent hose. With this hardness of the tube, you don't get the flexibility. Okay. So, the type of chemicals. This has a polypropylene tube. This has a cross-linked ultra-high molecular weight tube. This one will not take as many chemicals, but very, very close. So there shouldn't be much of a difference. You have to be very specific. If you have some specific chemicals in your place, find out the chemical, let your supervisor know, let management know, get back to us, we'll tell you what works and what does not work. And I can furnish charts for you to determine which kind of tubes, which hoses work or work not for you. And I covered the pressure on all of this. Very important that you don't overpressure hoses.
How did you call that again? Composite?
That's correct, a composite hose.
Composite.
Yeah, it's what the English dubbed it as, is a composite hose. Okay. What do we look for when operators use a hose? And this is to the meat of this meeting. What does an operator do? The first thing that an operator could do when he picks up a hose is to hopefully lay it flat and straight. That's the best case scenario, lay it flat. Once he lays it flat, then he looks at the outside cover to make sure that there are no abrasions or things like that where what is going to be showing? The braids, the reinforcements. And what happens if the reinforcements get contaminated with chemicals if you have no cover? They rot.
What is the maximum lifetime for each one?
Well, what is the maximum lifetime of a set of tires for a truck when you give it to a teenager or when you give it to a 90-year-old person?
It depends on the use.
Abuse. Abuse. A lot of these hoses can last a long time. There's no such thing as how long they last. It's most hoses are replaced because of abuse, not because of anything else. They can withstand a lot of that. Okay?
We can get into the testing of it in a while.
So anyway, so we're talking back again about the cover. The cover has to be, it has to be completely covering the braids inside that give you the working pressure. Okay, once that's breached, again, the braids, whether steel or polymer or whatever type they use, start rusting and rotting. You have a very toxic atmosphere in chemical plants. And it's very quickly to rot and rust. Once you give that, then the tube has no pressure rating whatsoever. So this is what you want to do, is to make sure that the operator looks at the hose, make sure there are no tears or rips and nothing showing. And let me show you what I'm talking about. Does everybody see this?
Yes.
Okay. This was handmade. I have hoses that I got from plants that it actually happened. From this plant, from many other plants before they came over here that we used. This is what happens. Once this breaks, then you can see, does everybody see the braid? You want to pass this around? Just take a look at the braid inside of that. Yeah. There is no braid. Okay. Do you see the braid? That's totally abraded away, that's gone. Okay. What else, as you saw this hose, what else did you look at? What else is the matter with that hose?
It's collapsed.
Collapsed it.
Smash.
Looks like it's been run over with a forklift or something.
The forklift is our partner in my business. We replace more hose because of forklifts. Now, you see the braid? It's all gone. There's no more pressure rating in this hose. Why does a lot of this happen? When people drag the hose around, they'll take forklifts and take hoses and drag them from one end of the plant to the other. And that. Then not only that they ruin the hose, the couplings themselves. Okay. Now, we were talking about forklifts. What would be, this is a $400 or $500 hose. It would be, what would you do when you ran across something like this? What would an operator do?
Put it out of service.
Oh, how about banging it out? And just,
No,
why?
gonna damage it.
It's already damaged, you're right. The problem is, once, as I remember, as I told you before, the cross-linked polyethylene, ultra-high molecular weight, is a very hard substance. Once you crush it, you crack the tube. And what is the function of the tube?
Convey chemical.
Chemicals. Okay. So now that this is cracked, where though do the chemicals go? Between the liners, the braiding, and that keeps it. And once that's gone, then all of a sudden it goes through the cover. And then a lot of times you'll see bubbles on the hose. Okay? The worst thing you can do is to take a knife or some sharp object and prick the bubble. We all know what happens. If it's acid, it's on you, or anything else. You leave it alone, completely out of service. This hose is gone. It's no longer functional. Okay? Now, a lot of failures in hose come from where the hoses are attached. How many of you people know when the hose is not quite there and you pull it and then this happens? How many times does that happen at a chemical plant, gentlemen? Ladies? A lot. Once you do this, you also breach the tube of the hose. More importantly, even than that, is you weaken the coupling system in the hose, because that's the last component of a hose, is the coupling system. Okay? Now, a lot of times when hoses get old, especially, I don't know, what parts of Africa are we talking about here? Angola? What is that? Okay, what's that? How hot does it get in the summers there?
90 degrees.
That's Celsius? Fahrenheit. Oh, that's all? Okay. How about Nigeria? Does it get hotter there? Okay. Heat and ultraviolet rays are not friends of hose and rubber. What happens is all the heat and the ultraviolet rays will actually leach out the plasticizers in the rubber, making them stiff and hard. Like an old tire on a truck. Sometimes when they get old, you see the cracks in it. That's from exposure to the sun and the heat. The same thing with that. And once you destroy the cover, again, what we're talking about goes back to the braiding part of it, the pressure component of it. Okay, so whenever people look at these things, they have to look to make sure there's no cracks in that, on that from use. When you see that, pull it out of service. Okay, let's talk about couplings. That's the fourth component of a hose. The first three components were the tube, the braiding, the cover. The fourth component is the coupling devices. Okay? You, gentlemen, I believe, use this kind of coupling device. Do you use any of these?
Yes.
Okay. Did you say yes?
Yes.
Would you come up here for a second? Okay. Couple this in there and see how. Okay.
It's loose. No
Why?
gasket. No gasket.
Do you think the operator should have checked for a gasket when he picks it up?
Yeah.
Okay. What else would you look at in the coupling?
Yeah, if it's worn, you know, like.
It's worn. Very good. Okay.
And
Let,
because if it's worn,
Yeah.
then it won't really
Right.
sit there. It was.
a lot of times, how about the pins on these older, these are the older gaskets.
Yeah.
These pins come out. All of a sudden you have an accident happening, especially in a lot of these older varieties of these. So it's important to keep these together. Use a device like this, because a lot of times if you don't slam it tight, they don't hold. Some operators will just somewhat put it like this and leave it like that. They have to go all the way down, and this is used. But I think we
Especially with the pump movement, it tends to come out. Mm-hmm.
That's correct.
Yeah.
That's why I use this. It's better to use this. This is a device that is getting away from this type of coupling. This is a dangerous coupling to use now. The pins that they use that came out of here, these are spring-loaded pins. The whole mechanism is a harder, stronger mechanism. And when an operator takes this thing and hits it, it's locked. Okay? That's good. If you want to put this on, that's okay. But you don't need to. There's no need to do that. So whenever you use these couplers, you have to make sure that what's in here, the gaskets. Okay, let's talk about the gaskets. There's always something. This gasket is a universal gasket that comes in here that takes 85–90% of the chemicals. What happens if you put acid through a hose? This hose is designed, the tube, to convey chemicals. This gets involved in the chemicals. This will see the chemical also. So you have to make sure the compatibility of the gasket in the coupling, where's the coupling device? Okay, in the coupling device is also compatible with the inner liner and what chemicals are going through it. They come in different varieties. A lot of times it's important, especially, well, it's always important. Every time you pick up a hose, somebody picks up a hose, look at the gasket. If it's soft, if it doesn't go right, pull it out. If everything else seems to be okay, sometimes with a lot of use, the gasket will collapse on itself. It'll just get softer and softer. You can buy thicker or get thicker gaskets to put in if everything else is. Yes, sir.
We're talking about the gasket. Do you have different classes of gaskets?
Yes, the gaskets come in as many varieties as you like, from Teflon, Viton, Calrez, everything combined. EPDM gaskets are good for chemicals. Buhner gaskets can be used for chemicals, some not. But indifferent with that, check the gasket material. Because not every rubber is good with every chemical. I don't know how many chemicals you have. So when the operator comes in, let them check, let them look. So we put that back in there. And make sure it's seating properly. The gasket's good. Then let's try and couple it now. You see how hard it is? Yeah. That's good. It has resistance. Just slam it.
Yeah. So,
Yes. Keep those out of the way.
kind of like an
Right.
office guy.
There you go. It's hard, but you want it to fit very snugly, and that's a good one. So remember, the gasket material has to be compatible with the rest of the hose, the inner hose, to make sure that it lasts as long as the hose does. The gaskets should be checked every day, every time the hose is used. Make sure the pins are here. These are much less problematic than the old variety. This is aluminum. The only reason I brought it for weight purposes, but aluminum should never be used in chemical plants. That's a negative, because it's just not a good material. It's very soft. Right. Now, do you remember when we were talking about somebody dragging the hose, and I told you that there's something else that it'll destroy when dragging it? The ends. Okay. Do you have a minute? Can you come on up? Or you can undo this if you would. It's a lot harder when it's a small piece, but it's a larger piece, it's much easier. Okay, let's go ahead and put it in here. This is another one, and put the same one in there.
It's not gonna fit.
Why?
It's smaller.
Is it, no, it's not smaller.
Smaller.
Well, it's not. No, this thing is collapsed already.
It's damaged.
Yes,
Damaged.
that's correct. It's not smaller.
That's right.
What happens when you drop a hose and you slam it down on concrete or something, it eggs the hose. All of a sudden, what I've seen people get a hammer, go out and use it again. Again, it's an accident for the poor operator. If that one operator doesn't get it, the next one will. We are our brother's keepers. We have to make sure the next person that uses the hose is as safe as the person that is using it initially. Okay, now is there anything else you see?
It's cracked.
Ah, it's cracked. Again, a heavy drop will crack that. So when we're looking at the hose, we're looking at the whole thing. There's no abrasion on the hose. There are no kinks, nothing on the hose. Then we look at that. How critically important is it? This is cracked. Sometimes it's not as obvious as this. Sometimes it'll crack ever so slightly where you'll still be able to put this in. It's been egged just enough, but it's cracked. The next person, the person after that, will use the hose and off it goes. Whatever chemical is being pumped will be on that person. Thank you very much. Okay. Let's talk about, we've talked about the chemical hoses. All this, we know we can't bend this as much. Of all these chemical hoses that we've seen, which of all of these do you think is the most dangerous? What, you?
Most dangerous? Maybe they can.
They're all dangerous, but
They own it.
Okay.
But
Okay. You're all correct. You're all correct. They're all dangerous. However, more accidents happen with the air hose. Why? Everybody knows what a whip is. As you crack a whip, the tip of the whip hits supersonic speeds and creates the crack when it hits past supersonic speeds. When an air hose is 150 pounds of pressure, 200 pounds of pressure, and it gets loose and it starts whipping, it hits you in the head, it's over.
R.I.P.
Completely over. When anybody uses hose, they have to they have to respect it as much as any other hose they use. It's very simple. These are called crowfoot type couplers, or the old-fashioned Chicago pneumatic type couplers. Okay, we need another volunteer here. Sir, come on by. We'll take a look at these hoses. Okay, I just put this on. I don't know if you can take this coupler off of here, off of this. Can you think you can take it off there? It's going to be hard.
Push E. Push G.
No PP.
That's good. I can't do it anyway.
Yeah, my
Okay.
hand slipped.
Okay, then let's go ahead and put this one on the other side. That'll be a lot easier. Huh. They got it on. Now,
No, it's not locked.
It's not
well,
there.
it's missing.
No gasket.
remember what I said? Check the gaskets. I'm sorry I had to do this to you. Thank you. The gasket's important. Always make sure the gaskets are in here. This type of hose, they fall out very easily. The operators need to make sure that they have gaskets. Okay, once you put this in, let's say there is a gasket in here. I have a gasket. This gasket, once we put it in, this is very, very important with air hose. You can put that through. Put this on, okay, and then you see the holes on the side? This key will go right, pardon me, through there. This makes it a much, much safer and probably save a lot of lives. Again, this is a very dangerous hose. This little key that should be attached to the end, you know, keep this on, have many of these. These are very inexpensive, and have them actually tied to the end of the hose that you don't forget it. And the gasket. Thank you, sir.
Yeah, thank you.
Okay, let's see. Now let's go back through here. And let's just pass this around. A lot of times when you buy hoses, you have hoses that have threaded nipples on them. And in your maintenance department, you put these on, okay? As we put these on, and make sure we Teflon tape them and put them on correctly, what you don't want to do is over-tighten stainless steel. You'll collapse the threads, and it's over and it'll leak, okay? Go through here and look at the hose. See if there's anything you see that you should do when you put the hose on. Oh, what happened here? Abrasion?
It's just getting damp.
Yeah.
The cover is almost gone.
Yeah, and what happens then with out? What else do you see? Okay, you're putting this on.
So I see.
Okay. So when you...
Is this a tape?
Oh yeah, that's tape. There's nothing else when you put it on here. Passes it around very quickly and see if anybody can see it. And the people that know it... Okay. The maintenance department, again, is critically when putting hoses together. A lot of the maintenance people should take care of the operator's responsibility to the next operator is to make sure that what he's using is safe. Okay.
Well,
Yeah, if I
you
may.
pointed out this right here, but also those are signs of the tools that they were using, but they're also on the coupling. You're not supposed to put any tools on this. That's part of it.
When you put these hoses together, that's correct. You see the tool marks on here? This is a ferrule. This is what crimps the hose. This is a very complex hose to put together. And there's a lot of epoxies and glues and rubber seals inside of this. By the time you screw it all together and then you crimp this, it forms a seal, a permanent seal. Maintenance departments will always take this, put this in a vise, and turn until this is tight. What happens when you hold on to the hose here? Yeah. What you do is you turn this and the coupling together till it turns despite this. You're breaking the seal that was put together on the hose when you do this. You break it, you have a leaker, there's a $750 hose gone. When people come in and put these things on, they need to grab it on the nipple itself. Hold on tight and then tighten it. Never, ever, ever grab a hose with a wrench on this part of the hose. As you go back to your plants, you may look through there and see if anybody's done it. If they've done it, test the hose, make sure that its integrity is correct, and put it back, but educate. Never grab it here, always grab it on the nipple. So there's nothing else turns except this on the thread. Okay, now let's take a look at another issue here. Does anybody see anything wrong here?
Stainless steel with carbon steel.
This is just a demonstration, but that's correct. Okay. You see how this nipple that goes into the hose is creeping out? Occasionally, that'll happen. This nipple creeps out from the hose. This is halfway out already. The more it's used, the more it's pulled, it'll come out. Again, you have a problem. The same goes with these hoses. The same go with these hoses. Look around, pass this around very quickly, and just say nothing but look at, see if you could see what I'm talking about. Important, when this happens, this hose is no longer functional. It goes out of service. Do you see the gap between the ferrule and the end? The fitting is creeping out. Again, this needs to be taken out of service. So we've covered handles and pins and rings, the kinks, the soft spots. What not to do, and we've covered this. What not to do with hose. This is very basic. Drag hose, pull hose with a forklift, run over it with tires. A lot of people won't move it. They'd rather go around it or go through it. Very expensive. What's critical about that is that same person that runs over it, another person may not know, use it, and it's already, the tube is cracked, and we have some serious problems. Okay? Use the wrong hose for the application. You saw the, where is the steam hose? You saw the steam hose. If you use this hose, and these hoses come in black also, if you use this hose in steam applications, you have a serious burn victim on your hands. Make sure the hose you use is for the proper application. Train the operators, make sure they know what they can and they cannot do. And if they ever have questions, they can only ask. Of course, leaving the hose out where it can be in harm's way, leaving it in the sun too long, not a good idea. It ages very quickly that way. Put wrenches, we've covered that, putting a wrench on the ferrules. Even pliers are not a good idea. Sometimes large pliers on here will start collapsing this ferrule. When it collapses this ferrule, the same effect happens, you break the seal. Hose, do you all pressure test your hose? Dave, what do you do with, you have a testing program. Every hose that we sell goes out tested. It's important, but that means nothing. It's tested once. Once it's used, there should be some kind of frequency in testing. And every chemical plant has its own parameters, what they work in, and you have to determine what you want to do. Dave, what do you do here?
The hoses in the energy services plants are in the mechanical integrity program as a piece of equipment like we talked about yesterday. When the hose comes on site, it is pre-tested before purchase. When the hose comes on site, we give it a unique identifier and stamp the date the hose was put into service, the location of the hose. And then that hose is taken out once a year and taken to our testing station in one of the plants, and it is visually inspected and then pressure tested. Then the date is changed in the database and changed on the hose tag that it was tested and put back in service. The testing equipment for West Africa is there. Well, did Matt say yesterday that they had received one set of it? So it's part of the program that you guys will be implementing in the future. The procedure is the same. The test equipment is basically the same. But the most important part of this is do not let the annual inspection determine just that inspection. The hose still needs to be visually inspected every day before use. And look for abuse, look for everything else that an operator would look for. The annual test is just to ensure that the integrity of the hose is still there and that the testing program is in place and working.
Thank you. Every plant is different. You have to determine how it's used, how often you should test it. But if it's a damaged hose, and after you test it, and if it's slightly damaged, you can determine yourselves what criteria you want to use it or not. Always err on the side of safety. But never, once it's damaged, get it out of service. Red tag it and out where nobody else can grab it. All right. Storing the hose. After use, what does your plant do? And
As far as where they're stored,
yeah,
racks,
on racks, outside, inside,
everything's outside.
outside.
Covered, but outside.
Oh, as long as it's covered. The heat will get it, but as long as you're covered from the UV rays. There are no mercury vapor lamps inside.
No,
Mercury vapor lamps are very bad on rubber, so you don't want to put it under mercury vapor lamps or fluorescent lamps. They're also not good. You mentioned nothing about cleaning the hose before you put it up. Are the hoses cleaned when you put them up?
Flush it,
Flushed with?
solvent.
Okay.
or water.
Is
Okay.
I mean, any solvent for that chemical. I mean,
Okay.
Water-based chemical has water as a solvent.
Okay,
And then-
but they are cleaned. Are they dried?
Dry?
It's usually a good idea to run some air through them, just to get most of the moisture out of them. It's always a good idea. And then they should be cleaned, put up on the racks, out of the sun, out of heat sources. That's what should be doing. We went back and looked at some of the wear and tear on some of the hoses. When you use the hoses, what happens on a lot of chemical plants, you put them in concrete and they vibrate. And they vibrate.
Quick question before you move on.
Yes.
When you put your hoses on the rack, is that the best practice to cap them or just leave
I would
them?
let them breathe. And never put them straight on the rack, put them circular, where whatever's inside will get out, they'll dry themselves after you do the initial drying. Always put them on an oval area so that they stay dry, okay?
And they can be, when you flush, like you said, you have water based chemical and oil based chemical. The water based chemical is flushed with water, and then the oil based chemical is flushed with.
Either
That-
diesel or naphtha.
That- That's fine.
So won't the diesel or naphtha have effects on the hose?
Very little on the chemical hoses. On this hose, again, not designed for, you can't do that with that. This air's air. Most of what you flush with is correct. You don't want to leave an acid in a hose. You don't want to leave the pure material in the hose. Try and get rid of most of that and keep it clean. Okay, that's just a general rule for every hose you use. Because if you don't clean it, sometimes an operator will take that hose that you haven't cleaned or cleaned it with something else and they use it in another product and contaminate a whole batch of product. And that happens very often. So you want to make sure it's very, very clean. Okay.
What if you have dedicated hoses, particular products? You have to clean them all the time.
If you use it, dedicated hoses, when you put them up for storage, yes, but not if you're using them, no. Only if you store them. If you're going to store them for more than a week or two, clean them.
Okay.
You know, but no, not in normal use if they're dedicated.
And that's the case actually in West Africa. Everybody using dedicated.
That's very. How do you determine by the coupling you use where it goes?
The color code.
The color coding. Okay.
Black white
Right.
is for oil and blue white is for water.
Okay,
That's chemical, so.
that's good. You can get these hoses in different colors also. If at one time you all might want to consider that every one of these hoses, the cover can be changed to the color you need. Okay?
That would be nice.
Yeah, actually, that's what we talk about. I was talking about this protector because we
Okay.
keep our hoses outside, and I think if we put on our hoses, especially in different colors, it would help us a lot. This way we can separate the oil from water, and at the same time we can protect it from the sun.
This is not as much will protect it from the sun, because the sun will have the same effect on this. This is a polypropylene. No, I'm sorry, this is a polyethylene product, and the sun will leach out that. The major objective of this is to protect the hose from vibration, from the rashes that these types, yes. And, yes. Now, along when you use that from the abrasion, as you put it in, as you see, it'll open up. It's difficult to put on, but once once you do this, what's good, you don't want to put a cover on the whole hose because you don't know where the prongs are inside the hose until it's too late. This one you can put on and to stop the abrasion from happening. This comes in many colors too. Safety orange, green, white. I think I have, I think somebody ordered some of this.
I talked to Mike about it.
Oh, Mike Valdez? Great, yeah. Here are the color combinations that comes in. Okay. Are there any questions at all? We're open. I've covered everything. There has to be some questions.
How did you call this one again?
Which one? Oh, this is just a sleeve, yeah, a protective sleeve. That's all it is. Yes.
One thing I was gonna mention, a collapse hose. Can you show them, or do you have an example of the collapse hose?
Well,
those
you're talking about-
composite collapse hoses?
Very few, if you, no, because usually the wire will spring back a little bit. So what you could tell when they're collapsed on that, this is what a lot of times happens when they collapse the hose. You'll start seeing wear and tear on one part of the hose. But a lot of these will bounce back. Not a good idea to use them if you know that's happening.
One thing, can I?
Yes, please.
One thing about these collapse hoses, even though it'll still hold its shape, you'll see the inside, the liner, it'll be collapsed. When it actually, if you guys ever get a chance to look at them, inside, the composite threads is gonna be twisted, mangled.
Right, and then all of a sudden they'll come out in pieces. It'll start coming out in pieces in the other end and it may clog up the whole system that you're trying to pump. Right.
Yeah. Can we, like, we're trying to, can we customize, like, if I instead of, like, say we color code our hoses by color coding the timber, I mean, the ferrule. Can we color code this, I mean, get these ones customized?
colors.
Yeah.
Well, yes and no. You can color code these, but they're very expensive and they're very rare. There are special custom people that will do that, but very, very, very expensive because they don't sell many of these. It's easier to color code the actual hose. This is not bad. I think the minimum requirement for a hose to color code it is either 200 feet or 300 feet. So if you're buying a lot of hoses for a time, you know, let purchasing know, and we'll have that color for you, dedicated for you for the colors. But they can be gotten in different colors.
Excuse me. Looking at this composite hose, that outside ring there, does this have any purpose for bonding?
I'm sorry? No.
This outside ring on
Yes.
it, does this have any purpose for bonding?
No. Well, you're talking about continuity
Bonding and grounding.
and grounding. Yes, continuity. Yes, the bonding is, this is all metal. This hose, this stainless steel, touches this.
Okay.
Okay? The continuity goes straight through the hose, all the way through. Is that what am I answering the question?
Yes.
Right, yes, that is what this is used. As a matter of fact, if you look in, let's see if some of these hoses, I didn't bring up, where is that? No, this. Look at the inside of this hose. If you look, you see the wire.
Yeah.
That's a steel wire that's put inside the hose. Then the coupling is put inside that touches the wire. This is why we do this, is to have continuity in the hose. But it's always a good idea. It's very simple to check continuity of hose. And not only if the hose has continuity, you have to check the rest of the system, each piece at a time, to make sure it all has continuity. This may have continuity, but if downstream doesn't, it matters not. So all of the parts. Yes, ma'am.
So I have a question. So does it mean that with these hoses, I mean, the contact is more than enough, and then you won't probably need to do any other form of external bonding and grounding?
Yes, but it's still a good idea to check. Every now and then, check the continuity. It's a little meter. It's very, very simple. One end to the other end, and you'll check the continuity. But yes, it's usually enough. On these hoses, it's more than enough. And this, you have to worry about the whole system's continuity, not just the hose.
thing also, even though it's not, well, I know it's part of the hoses, but if you look at the cam locks, if you have two different manufacturers of cam locks, sometimes they won't have complete seals.
Yeah. All of these cam locks, these are what they call them, cabin groove cam locks, they all are made to a military spec. And everything from 1 inch through 6 inch is military spec in the United States. Unfortunately, you have things made in other countries that go on the minimum side of the spec, and another factory in the same country would go to the maximum side of the spec, and all of a sudden you start having that problem. But usually if you buy Dixon, other companies in the United States, they're very rigid as to the quality control, and they all should marry. Above 6 inch, there's no spec. You have to marry one with the same manufacturer of the other. But they all should fit. If they're not, then you have to determine who you're buying that other one from, where it comes from.
Well, because ours is mostly West Africa. That's why, even though we're gonna get our equipment from the US, but there's also other containers or hoses
That come in.
that come from other
Yeah.
countries.
It's
Where it's gonna be an issue.
unfortunately, there's so many everybody manufactures cam locks. We only buy the ones from the certified people that make these. It's because of that lack of control, of quality control from third world countries that do that. You know, from Vietnam and places like that. They mass produce them at a very cheap cost, and it's not a good product. And you've seen that then
Yes, I've seen it,
firsthand.
and At first, you're like puzzled.
Right.
Why? But when you come and investigate it, come to find out
Quality is just
different
Yeah.
quality.
Right. Okay. Other questions? I'm sorry you had to look at my back here. Okay, well, yes.
What did you call the black protection again? For the
it's the
This, yeah.
Okay. My question is, if you use it for host during inspection, maybe if there is a crack, is it not going to kind of cover the crack?
Correct. You're exactly right. Usually, you won't see it because the abrasion is, or the cracks, you won't see it through here. But it's less likely that something will happen to it with this on it. But if you really want to make sure, you can take this off. But once this is stretched on, it'll be very loose the next time around. But usually it's like this, and if you're real careful, it's not just one little crack. If it's underneath here, it's probably very improbable that you'll have something underneath this. But at least you'll be able to see the hose.
And I think you can move it from one place to another,
Yes.
so you can clearly visually
Yes,
inspect it.
that's great. And you can actually move this in and out,
Yeah.
you know, and you can check that.
Don't they have the little cradles we can sit them in also?
There are cradles. You know where do you get those cradles? There are cradles that are made, or you can make them in-house. That'll keep them off of the concrete and that. Just keep them in a cradle. Or a rubber pad. A good rubber pad for a chemical plant will be made probably out of EPDM material. It's a rubber that's very resistant to most chemicals, and it's inexpensive. And you can get a 1/4 inch, 1/2 inch piece of pad. If you know there's a huge amount of abrasion, you can use that pad. Just order strips of it, cut it to where you want to put it. Or sometimes around a steel girder, where people come around, put the piece of rubber around there, where it won't abrade the hose.
On that air hose, is the safety pin enough, or do I have to go further and put like a whip check?
You can put a whip check. If you're running at 70 or 120 pounds, that's plenty. You can use a whip check. Most people use a whip check because almost nobody uses these. So you can put a whip check from one to the other. Yes.
Okay.
That's a double safety mechanism. But you won't need it if this
it
is...
should be okay if you have
if
this
you
safety.
use this, right. And the gaskets and all that is in there.
Have you got any sort of safety concerns about interlocking hoses together? So quite often, you know, the distance between the tank and, you know, one tank and the other is quite quite long, so one hose is not sufficient. So we'll have to lock them together. What's the concerns on that at all?
No concerns, as long as the integrity, and we talked about the integrity, as long as the coupling is good, the hose is good, there's no problem. Make sure that the ears are down. That's all. Make sure they are down. There should be no problem. Now, if you want to go 400 or 500 feet, then we're talking about pressure problems.
Yeah.
Then the pump is not going to pump as well because of the length it has to pump.
Yeah.
But no problem.
I have a question for Frederick. I don't know if in Sugarland, if we do the hose testing, hydro test ourselves, or we have a vendor doing it for us.
Okay, you have a vendor doing it
I'm
for you?
asking if in Sugarland, if we do the hose testing ourselves.
We do, the hose testing is done in-house.
Okay.
No vendor. You'll see it during your tour.
Okay.
They have a hose testing station. And we have sent the hose testing procedure to Malongo with the testing equipment, and then there can be some additional training. It's a very simple procedure once you do it, and it would be a choice to have vendors to do it in your area. But I think in Malongo, they're going to do it themselves there. Is that right, Ed?
Yes. We just got it customs cleared.
So they will have to be trained, because there's a lot of liability issue handling this, because the test pressure is close to like over 50 pounds, right?
How many pounds?
If you have the test pressure should be about like between 50 to 80 psi.
Yeah, the test pressure on a hose, you have two pressures. Test pressure is 1.5 times whatever pressure you use in a chemical plant. Each hose has a pressure factor, a safety factor. Usually on this hose, on the Parker-Hannifin hoses, is 4-to-1. So if it says it's 250 pounds, it'll burst. If everything else being correct, it'll burst at 1,000 pounds. The reason you never, ever want to tell people about a safety factor is because they think the hose can be used over its actual, working pressure. The working pressure is the working pressure. The more you test it at 1.5 times, 2 times, whatever you test it, the more you press your hose up, the weaker it gets, like anything else. The more you test, the more you test, the more you test, it gets weaker. So you don't want to test it at 500 pounds. Yes, after 3 or 4 times, you're really stretching that hose.
So the recommendation would be maybe once a year?
Once a year?
Annually.
Yes, that's what we do in.
What you do here?
Yes,
Okay.
there's probably 600 hoses in the database there, though. It's
Okay.
quite extensive. But the thing, when you're testing a hose and being trained to test the hose, it's usually at the working pressure of your plant. The maximum working pressure at most of your facilities is probably going to be 100 to 150 psi, even at that. Is that correct?
Yes.
Yeah. That's
So
my
you would set your test pressure at 150 psi, and of course it's done with water. So there'll be some training involved in it, and some education, and I think Carl and Fidel would be great resources for that because they've been around it quite a few times. But you're exactly right. If you're going to test them in-house, you need to train your maintenance personnel on the test procedure and how to use the equipment. But once again, it's very simple.
Okay. Now, if I may mention something else. As I told you, you have 1,000-pound burst pressure on this. But we forget that the burst pressure on the cam lock is not 1,000 pounds. So this is why, if you tell somebody, don't even mention that. Working pressures within that area, that's where they need to stay. Okay? These are not good for 1,000 pounds. Okay?
The people trained to test this, are you going to certify them, or do they need a type of certification, or just?
You're talking about a hose certification for testing? No. It would be following the OJT module on the job training and the procedure that we have. So you would, if maintenance is testing your hoses there, then they could either, someone from here go over to teach them, or they come to Sugar Land and use the hose testing station here to learn how to test the hoses.
Management in all the chemical plants can self-certify the operators or the testers by going over the basic rules. If they know how they're doing, check them 2 or 3 times, you can certify them within the plant, for that plant only. You know, it just takes...
But in Nigeria, it's kind of different. They have a Department of Petroleum Resources requires that for those kind of, they call them high-risk job, because it's more than 5 PSI. They require some form of certification before they can do that. That's the question.
Okay, over 5 PSI?
Yeah.
It's high risk?
Yeah.
Oh, that's, you know, it gets back to these low pressure that can kill you. It's usually a good idea. 5 pounds, and never test with air. Never test with air. You always want to test with water or fluid. And remember, air can be compressed, liquids cannot. That's how hydraulics work. Okay, if there's anything else, thank you very much for your attention.
Thank you for your time.
Appreciate you inviting me. Thank you.
I'm not saying well cost here.
That's good.
There's no well cost.
Costs?
Well cost.
Wilcox.
The brand.
Oh,
Wilcox make that hoses.
yeah, the Wilcox, I'm sorry, we had just so many. We use Parker Hannifin. Parker Hannifin is a large corporation. Wilcox and Parker Hannifin make the same hose. We send out. They're hard to get, you know, but if you need some, I will send. If you let me know, I'll supply all the catalogs you need. I will also get some chemical charts for all of you that you can determine which, you know, chemical goes with what tube compound. Okay, if you let me know, I'll get the catalogs to all of you if you need them. Okay.
Thank you, guys.
Thank you.